Hello everyone, good day. My name is Aswa Pascal, and today's tutorial is coming to you from the National Fellowship of Christian Pharmacy Students. And today we are going to be talking about suppository. But before we go into the calculation of this practical course, we are going to talk about suppository. What are suppository? Suppository are solid dosage preparations that are meant to be inserted into the body cavity, depending on the area of the body cavity that suppository are being inserted into, which can be the vaginal route, the rectum, the urethra. Suppository are called pessaries, bulges, and simply suppositories. But before then, we are going to be talking about how suppositories are prepared. Now, in preparing suppositories, we make use of two primary excipients. We make use of the base and the medicament. These medicaments, which can usually poison, like ethylene hydrochlorate and chlorohydrate, for these particular examples. Now, there are three types of bases that are used in the preparation of suppository: fatty soluble bases and water soluble bases. For fatty soluble bases, we have cocoa butter, goat fat, and many other examples. Then for water soluble bases, we have like glycerol gelatin, polyethylene glycol, and many other types there. Now, but before then, we will talk about an important concept which is called displacement value. Now, displacement value is the weight of a drug that will displace one part of a base. Right? In preparation of suppository, what we do is we weigh out our bases into our crucible. Then once we weigh our bases into our crucible, the medicament, which in this case is carbohydrates, is now weighed into the crucible. Now it's weighed into a crucible on a Bunsen burner to melt the base, right? Then the medicament is now put into the crucible, and the mixture is now titrated to obtain a homogeneous mixture. Then this homogeneous mixture is now used to fill cavities. Now, in preparation of suppositories in the lab, there was what we call suppository mold cavities. These cavities are where our liquid preparations are being poured in, and they are refrigerated to form solid bases, solid suppositories. Now, but before we go into the details of the practical, we're going to answer this question. Now, this prescription talks about chlorohydrate 600 milligram, and we are using goat fat to 1 milligram. So we are going to be finding the amount or the weight of the goat fat we are going to be using for this particular question. And we say we should make suppository and send 6 suppository. Now this is a solid dosage preparation, and we need to add an overage of 2. So when we say 6 plus 2, which is our overage, we have 8 suppositories, right? And one suppository would contain 60 milligrams of our API, which is chlorohydrate here. Then 8 suppository is equals to X, which would give us 460, I guess. Should give us 480 milligram. Now this milligram, to converting this thing to gram, we divide this by 1,000, 0.48 milligram. It then shows us that 0.48 milligram of chlorohydrate is needed for the preparation. Chlorohydrate is needed for the preparation of our suppositories, right? Needed for our supposition. Now we've gotten the amount of chlorohydrate that is needed for preparation of 8 suppositories. Now we are doing 8 because this is a solid dosage preparation, and we are taking into consideration of transference losses, right? So it's better we err on the side of having excess than having less. That's why we usually add this overage. Now we have 8, but we're actually sending 6. Now we go into calculating the amount of goat fat that is needed for this particular prescription, and what we do is we make use of a formula which is given like this. Now, in calculating the amount of base that we need, this is the formula. This N is the number of suppositories, in this case, which is 8, and W is the weight of the mold. Now, one of the key factors it's important for you to note is that when we are preparing suppository, based on the type of bases we use, which is either fatty soluble bases or water soluble bases, at the end of the day, after filling up our mold cavities with the liquid in our crucible, the weight of the suppository is going to be dependent on which base we use. For goat fat, the weight of the suppository is going to be 1 gram, and when we use water soluble bases, it's going to be 1.2 gram, right? So the number of suppository here is going to be 8 multiplied by the weight of our mode. Now the weight of our mode, because this is a fatty soluble base, is going to be 1, right? So we're multiplying it by 1 minus weight, and this is going to be our weight of our drug, which are weight of our medicament, which is 0.48. 0.48 divided by the displacement value of our chlorohydrate, which is 1.4. So when we do this, we would have 8 minus 0.34, which gives us 7.66, approximately 7.7 gram of goat fat. So 7. So our working formula is then this. Our working formula is then for chlorohydrates. Chlorohydrate is going to be 0.48 gram. Then goat fat. Remember, goat fat is a fatty soluble suppository. Goat fat is going to be 7.7 gram, right? So what we are going to do with this thing we've gotten is to weigh. Now, goat fat is a fat in the lab, I would say it's a sticky excipient. It's very sticky, but it melts when you heat it in a Bunsen burner. So what you do is weigh out 7.7 gram of goat fat into your crucible. Now your crucible is inside your water bath. So you put it in the water bath to be able to melt this goat fat. So when you put it in your crucible, when about 1/3 of it is melted already in the crucible, and you keep stirring it, you now measure 0.48 gram. Now I'm talking about the procedures here. You now measure 0.48 gram into the same crucible and keep stirring it, then to the point till it's about to get to solidify. Then you now bring it out. Then you now fill up the pre-lubricated mold cavity. It's usually 6, so you now fill 6. Now it's important for you to note that you are only filling 6 and not 8. The reason why it's 8 is because we added an overage of 2, which we did considering transference losses. So you're going to fill up 6 cavities of the suppository mold. But note that before you fill up this suppository mold, you must have lubricated the suppository mold with either glycerol or alcohol or which other lubricant is given to you in the lab, and you invert it to drain off the excess lubricants, because if it's not drained out, it will contribute to adding to the medicaments of suppository, and our product might get contaminated. So this is it for this calculation, and the procedure is just as I have stated. Then in writing our label, you note that this is a poison. Chlorohydrate is a poison, and it's usually being measured from the poison box. And it's important that you note that when you measure this poison from the poison box, you note it in your poison books and you include it in your procedures. It gives an extra mark. So our label is going to be written like this. Because we sent 6, it's going to be 6 here. I'm writing the suppository then the weight is 1 gram. 1 gram because we used fatty soluble base as our base here. Goat fat is an example of fatty soluble base. 1 gram. Then chlorohydrate, 60 milligram. Goat fat. Remember, you're not writing your working formula here, it's just the original formula. US 1 gram. Then direction, you interpret. Direction is going to be insert as directed by physician. Directed. Okay. Well, name. Well, before this. Now, in your auxiliary label, you're going to write at the top of your poison with a red pen because chlorohydrate is a poison. So then your auxiliary label is going to be, you are going to write store in a cool, dry place. Now for this question, I must repeat certain procedures that are here. And one of it is when you are taking your chlorohydrate, which is a poison, you take note of it and record it in your poison box, right? And you make sure you write it in your, include it in your procedures, right? So over to the next questions, we're going to be talking and giving an example about another type of suppository. Now for this next question, we're going to be solving, interpreting this prescription. Chlorohydrate 80 milligram, and say we should send 6 1 gram suppository. Use goat fat as our base. Now because we are using goat fat as our base, which is an example of a fatty soluble base, the weight of our base is going to be 1 gram, so it's going to be reflected in our calculation when we are getting the amount of base we are using for this particular preparation. So we'll start by saying that one suppository, well, first of all, we are sending 6 plus 2, which is our overage, will give us 8 suppository. So one suppository contains 80 milligram. 8 suppository now contains 640 milligram. 640 milligram. Now, converting this milligram to gram, by 1,000 would get 0.64 gram of chlorohydrate. Right? Then to get our amount of base that we use for this particular preparation, remember our previous formula, which is number of suppository multiplied by weight of mold minus the weight of our medicament divided by the displacement value. The number of suppository here, we're going to be using 8 multiplied by 1 because the base we are using here is a fatty soluble base, minus by weight of our drug, which is 0.64, divided by the displacement value of chlorohydrate. The displacement value of chlorohydrate is still 1.4. So when we do this, we're getting 8 minus 0.46, it gives us 7.5 gram of goat fat. So our working formula will then be chlorohydrate getting a total of 0.64 gram and goat fat 7.5 gram. So our procedure for this particular practical is going to be like, after an appropriate calculation was done, 7.5 gram of goat fat was weighed into a crucible in a water bath and was now melted to a point. Then chlorohydrate, 0.64 gram of chlorohydrate was now measured into the crucible and was now mixed till a homogeneous mixture was formed. The mixture was now used to fill up 6 cavities of our suppository mold. But you note that before filling up the 6 cavities, you must have lubricated the cavities and inserted it so that the excess lubricants will be removed. So you take note of this during your calculation, and the label is much like the one we did in the previous question. So we're not going to be writing the label here. So over to the next question. We are going to be using water-soluble base as our next base in preparation of our suppository. So over to the next question. Now, over to this next question. We are preparing propane hydrochloride glycerol gelatin. Now, you note the difference between this question and the one we've been solving before is glycerol gelatin. And glycerol gelatin is an example of water-soluble base. And because of that, the weight of the suppository we are going to get after extracting our suppository from our suppository mold is going to be 1.2 gram, which is greater than 1 gram of fatty soluble bases. So the weight of suppository that we get when we use water-soluble base is going to be 1.2 gram, and we will take that into consideration. Now, this question says we should prepare suppository and send 6. We are sending 6. Now, because we are sending 6, we are adding 2 as our overage to get a mean value of 8, right? So, number of suppository here. Now, because the weight of suppository formed by water-soluble base is 1.2 gram, we are going to be taking that into consideration in the number of suppository we are preparing. So, we are going to say number of suppository we are preparing is going to be 8 multiplied by the weight of this suppository prepared using water-soluble base is going to give us the number 9.6. So the actual weight, number of suppository we are actually preparing here is 9.6, but we are sending 6. Right? So the amount of drug, which is propylene hydrochloride, is going to be 8 multiplied by 1.2, which has a weight of our mode, multiplied by 1%, which is 0.096, approximately 0.1 gram, 0.1 gram. Now, to get the weight of our base, what we are going to be using, we're going to use a formula which is quite different from the one we use when we're preparing using fatty soluble base. And also, because of the fact that this prescription is given in percentage, we are going to use a different formula this time, which is number of suppository multiplied by weight of our mode minus number of suppository weight of mode multiplied by the concentration of our original drug, right? The amount of drug in the old formula. Now, in this old formula, right? So what we are going to do is 8 multiplied by 1.2 minus 8 multiplied by 1.2 multiplied by 0.01. Now, this x is the amount of drug in the old formula. Our old formula is this, and when 1% is the same thing as 0.01. So when we do this, we're going to get 9.6 minus 0.096 gram, which is 9.5 gram, right? Remember, what we are calculating here is the amount of base, we are going to be using. Amount of base we're going to be using to prepare this suppository. Now, it's going to be 9.5. Remember, right? So 9.5. Now, for glycerol gelatin, it's not usually a single base. It usually comes in as glycerol and gelatin. So it's your responsibility to prepare this in the lab. Or how can you prepare this in the lab when you don't have the formula? That's why your codex is very important. So when you go to your codex, you're going to find this formula of glycerin gelatin here as 70 grams. Now, this is the standard formula of glycerin gelatin. Then gelatin is 14 grams in purified water. To 100 ml, right? Now, what we are preparing is 9.5 grams, and we say we should purify water to 100 ml. So, because this thing is going to be a liquid preparation, we are going to get multiplication factor. And multiplication factor here is going to be amount to prepare, which is 9.5 gram. 9.5 gram divided, it's going to be divided by 100 amount given. Now, water is 100 ml, or for us to get our multiplication factor, remember multiplication factor is usually without unit. For us to get our multiplication factor, the 2 units here must be equal. So we're converting this 100 ml of water to gram. Remember, density is mass over volume. We're trying to convert this volume of water to grams. So in getting our mass, and density of water is 1. Our mass is going to be, the mass of water here is going to be 100 grams. 100 grams. So I hope that's understandable. So 100 grams divide 9.5 grams divided by 100 grams is going to give us multiplication factor of 0.095. 0.095. Now, we're going to use this multiplication factor to get our working formula for this glycerol gelatin. So our working formula is going to be 0.095 multiplied by 70 here, 0.95 0.095. So when 70 multiplied by 0.095, we're going to be getting 6.7 gram for glycerin. Then for gelatin here is going to be 1.3 gram. 1.3 gram. Then for purified water here, naturally 9.5 ml, right? And these are working formula, right? So how do we do this? How do we prepare this preparation? So what we're going to be doing now, glycerin is a liquid. It's liquid, and what we are getting here is 6.7 gram. So because it's a liquid, when we use our formula for density, which is mass over volume, we are trying to get it, because glycerin is giving it to us in liquid, we are going to converting this gram to volume. So when we do that, we're going to be having volume is going to be mass over density. Now you find the volume of the density of glycerin from your Clodex, and the density of glycerin is 1.2575, which is going to be 6.7 divided by the density of glycerin, 1.2575, which gives us a volume of 5.3 ml of glycerin. So we are going to be using 5.3 ml. This 5.3 ml of glycerin is equivalent to 6.7 gram of what we have here. Now gelatin is usually in solid, so we're just going to get it and titrate it to get, or size reduce it to size reduce it. Then what we're going to be doing is, how prepare this is going to be, we'll be off this thing please. There's a space I stopped.